Hi. So here we're going to start out with the talking about the triple constraint here. I'm going to go ahead and bring this up. I'm going to go quickly through some of this. The charts themselves are out there. Spend some time digging into them. Um, the triple constraint is going to be the main driver for success or failure on the project. Time, scope, and cost. Any of those things change, it impacts the other two. That's the reason it's called the triple constraint. So in project management, we went through all the, we talked about all these different areas, knowledge areas that you need to be on, knowledge domains that you need to be able to manage, suppliers, people, risk. All that's important. Being able to integrate that in a project management process is key. Triple constraint we're talking about especially because this is really the key management technique you need to understand. It breaks up into scope, time, and cost, or scope, schedule, and cost. And the scope processes are defined here. A lot of things about looking at your scope, planning it, defining it, creating a work breakdown structure, verifying it, and moving forward. Think about this as your requirements for the project, right? That's what we're really doing. And a lot of stuff that you do with scope is there's these documents that you make, scope management plan, the project charter. These are all scope documents. Very important for this part of it because this is what the project keeps coming back to. When someone says they want to add something into the project or extend it out or do something else, you got to go back and say, look, what are we trying to accomplish with this? I got some samples here for a charter and project scope statement, but basically that's what those really do. They really help to keep you defined. That's why there's signatures all over this. They say, this is what we're going to do, so what we're not going to do. Here's going to be, it gives you that sort of foundational element to start the project and to keep your idea of what true success criteria are going to be. And so the different definitions I've got here, success criteria, say, of all the requirements that we got, there's some that we absolutely have to do. Those are the success criteria. Those are the things you really want to understand up front because they're going to shape the overall flavor of the project. Acceptance criteria are very similar to that. So for this to actually be complete, what do the users need to be able to accept this and to move on? If they don't have these things, they won't even accept it, which means it's a failure. So you got to understand those two as you move forward. Work breakdown structure basically says this is of all the deliverables I've got, I'm going to break down all of the elements of the deliverables into decomposed objects of work. So it's decomposition, subdividing those project deliverables into much smaller pieces that can then be broken up into actual work packages, which is what you kind of get to when you kind of break down a WBS. Here I got it in an outline form. But if you look at what we got for a web page here, we got concept, then we got website design, website development, and rollout. And we break out that first one, you've got some requirements phases. And the requirements 1.2, you can break out further into define user requirements, define content requirements, define all of those things. What you're really doing is breaking down what actually needs to be done in this project. When you can assign those to dates, then you come up with a schedule, right? So we've got the WBS basically in a Gantt chart here, the work breakdown structures on the left, all the things that we just saw, and then the schedule basically assigns those to a time period. What those become then when they're assigned onto a schedule, they become activities. And that's where you get to a more detailed version of your work breakdown structure. Now you've got realistic cost and duration estimates that you're assigning to them, including predecessors, successors, what are our relationships to other tasks, other lead and lag times, other imposed constraints on this, those kinds of things that define really those activities. When you have all those definitions and those what the predecessors and successors are, then you can sequence them, right? Because you know what the dependencies are. Some dependencies are mandatory, like I need to purchase hardware before I can implement it. Some are discretionary, like around resources that might not be available or could be available, or maybe you could go out and get others, so it's kind of discretionary. External dependencies then are about like regulatory, look, we got to get done by the end of the year, that kind of thing. And there's multiple mechanisms for diagramming all those dependencies. But basically, once you get that, then you do the estimating itself to look at the durations. There's a couple of ways to do that. Keep in mind that duration is not the same as effort. So it may require 40 hours of effort, but the duration may be over 2 weeks based on the people that you've got available to work it. So there are two kinds of things that you need to keep in mind there. When you're trying to create the estimates of time, and we'll talk about cost estimates later, we use sometimes a PERT average, which is basically if everything goes great that's your optimistic time. If everything really goes poorly, that's your pessimistic time. And then what's your most likely time? What do you think it's actually going to take? You 4 times the most likely, and then you add in the optimistic and pessimistic, divide the whole thing by 6. That's the schedule. It seems to work pretty well. So that's the kind of timeline that you give to a task, and then you put it into this Gantt arrangement. Basically, you've sequenced, you've got the durations for each of them, and then you can start to add things like milestones, summary tasks to help you organize things, to help understand how much cost is being spent, all those kinds of things. Important to know when we're doing scheduling, reduce the multitasking. This is an important concept that it's very seductive to start a lot of tasks because it seems like you're making a lot of progress. A lot of things are going on at once. But what winds up happening here is in any project, you have those dependencies. And if I have a dependency, some other person has a dependency on task 1 be complete, but I've started to assign this person who's doing task 1 3 tasks at the same time. So, hey, get started on this, get started on that, get started on that. What winds up happening is that task 1 delivery is getting pushed out all the way to the right there, you can see. And that person that's sitting there waiting for that, when it was supposed to get done, because that person absorbed a couple other tasks, they're not going to get it till much later. And that's going to have a ripple effect in the project delays. And so you have these huge amount of project delays. Not to mention the fact that all this context switching pushes, even if you didn't have those delays, you're pushing out the whole duration by a fairly significant amount by all the context switching people have to do. That means when you stop doing a task and you start doing something else, you may not remember to write down everything you were doing when you stopped that one. And you didn't write it down last time when you started the second one. So you're trying to figure out where you are. You're spending time trying to get your brain back around it. And you're probably going to introduce problems as well because you're going to have errors that come into that. So the whole thing is it's a bad scene. Reduce your multitasking. Some good advice here on good schedule control, reality checks on your schedules. Allow for contingencies. Make sure you get buffers in there. Don't pad your tasks. Use actual buffers, okay? That's a bad practice. People think, well, it's going to take me 10 days to finish, so I'm going to tell them it takes me 15. Then you just look like you don't know how to schedule. If you put buffers based on realistic estimates, then you understand over time how you're estimating your buffers, and that works out a lot better. Don't plan on everyone working 100% of the time. That's a bad plan because they're going to get pulled in to do other things, and then you're going to not have any time for overtime or anything else like that to get people going in at the end of the project. Tools and techniques, progress reports, a change control system for schedule, just like you have a change control system for your scope, is going to be key. Managing the schedule, a couple of main ways here. The Gantt chart way that we showed, this is the percent complete way. This is the way most people think of it, right? I'm this far done on this task, this far done. Another good way to do some of these tasks, especially if it's software, is the agile burn down technique, where between now and the next sprint, what are the things I know need to get done? And you can have people sort of work everything until the whole thing gets done. It's a great team approach. It allows for a lot of collaboration, a lot of really maximization of your resources, and tends to be more efficient, okay, if you can figure out how to make that work for the project. If you have changes due to the schedule, always work your critical path method. So basically, critical path says, what's the thread of activities that are on the critical path where no matter what else happens in the project, these are going to take the longest amount of time to get done. Find that and try to take the time out of those tasks because that'll be where you can actually pull the entire schedule back. You can also crash, adding people, adding resources and stuff. There's benefits and drawbacks to that. Fast track, do things in parallel. Sometimes as you're working a project, it's broad enough, you can say, wait a minute, we can move this chunk. I just realized we can move this chunk and do this at the same time, and it won't clobber the resources, but we can get stuff done. Sometimes I didn't stand out early because you don't know where the problems are going to come up. Sometimes you can come in and fast track it. And as always, look at your scope. I mean, something that was real important early on, now that you're getting closer, it may not be that important now. You can figure out some workarounds if you can get the whole project just to finish up. Final thing we talk about is cost. So you have cost processes as well here, estimating, budgeting, and cost control, which we'll go into. Some definitions here that are useful, I think, going forward. Understand the difference between tangible costs and intangible costs. Both of them are important, okay? Intangible costs tend to be the things that will benefit the company long-term. Tangible costs are things you need to allocate for and manage in the project itself. You don't want to lose sight of either of them. Likewise, direct costs and indirect costs. You've got to manage both of those in a good project. So when you're budgeting for a project, obviously direct costs are key, but those indirect costs are going to wind up costing the company as well. So make sure you're reflecting those in your budgeting principles. Sunk cost is a principle I want to make sure people understand. If you're a year into a project and you've spent $1 million and there's another $1 million left to go, and you realize that, well, actually, the customers are moving in a different direction and we don't think there's a value. There's a tendency for a lot of people to say, well, we've already spent $1 million, let's just finish it up. There's no value in that. It's sunk cost. Always make your decisions and costs based on the value you're going to get going forward. Learning curve theory is another one that says, look, if I'm doing a task 50 different times, I'm probably going to get better at it. So from a cost standpoint, it's another good thing to know about, because if you're producing something, it's probably going to get cheaper as you go. And then reserves, we talked about reserves. As you're doing a technology project, make sure you've got contingency reserves to allow for known unknowns that are going to come up, risks that you know are out there. Management reserves are for risks that you don't even know are out there, right? Which can happen a lot in technology programs. Don't begin a project without reserves. Cost estimating. So there's 3 different ways of coming up with estimates. Before you decide to pursue something, there's a rough order of magnitude. Look, we think this is a good idea. We think it'll cost about $1 million. Fine, we think it's worth that. If it's $2 million, it's probably not worth it. Then as you get towards the budgeting the next year, then you've got a budgetary estimate that says here's what it's going to actually cost. And then definitive is when you get down to actually scheduling the thing out. This is what each week we need to have the cost, we need to have paying people, we need suppliers, all that stuff needs to be definitive. So all I'm saying is that as you refine the project, you don't have to have a definitive cost like 2 years out. You just need to understand kind of what's the impact of this project going to be. A number of ways to come up with those costs too. Analogous or top-down estimates basically said, I did a previous project, it was something like this, so I'm going to use that as a basis, and I'll change a few things, based on how it's changed. Bottom-up estimate is basically when you say, I don't know how much it's going to cost, but let's take the WBS, let's cost out each element of it, and then build up the cost of the project. And the parametric is, we do these all the time, and they change a lot based on certain characteristics. So the number of users is bigger, it's going to be a lot bigger. So think about things like workstation deployment projects. I mean, those are parametric. How many am I going? How many desktops am I visiting? Those would be parametric kinds of things. Typical problems with cost estimates, they're done too quickly. You don't have the experience to get it right. We tend to be biased towards underestimation. And a lot of times management desires accuracy that you just don't have. And so you make mistakes along those lines. Cost budgeting then says, okay, I've got the money allocated. How do I estimate it? How do I budget that over time to get all these particular work items done? What you do in the process of this, you develop a cost baseline. It basically says time phase approach based on the way the WBS has me laid out for supplies and labor and stuff. Here's where I'm going to be spending my money and how I'm going to be spending the money as I go. You will have variances, right? If you get a variance in your cost, you can do a couple things. One, you can ignore it. Small variances, maybe it's okay, it'll wind up going forward. Or I can just apply some of my management reserve to it, right? I can move resources around to adjust without significant adjustment in the plan. I can revise the plan and say, well, I'm already looking at the activities and reallocating stuff to reflect the facts on the ground in terms of cost. Or, if things are just going south, you can just cancel. I mean, that's just, it's the way it is. Those are the options you got. Changes to the budget should be managed in a controlled manner, just the way everything else does for scope and for time. You've got some changes that can come from flawed estimates, right? We just didn't get it right. You can have unknown unknowns pop up. You can have where you can use the reserves and such. If you have flawed estimates, you got to rework your estimate to complete and just move forward from there. Variances, use reserves. Permanent variances, changes in material price, those kinds of things. Again, you can use reserves, or if they're big, you got to go replan, cost, scope, schedule, or potentially cancel it. So that's a basic introduction to the triple constraint. All scope, cost, and time have to be managed. There's a control process for each of those. And make sure as you're going through your project management and integrating all those processes that you're executing those control processes so that you can make sure that you're reflecting changes in the other two when any of those change in schedule, time, or cost.